Hey everyone, it is Miss Gill doing a Module 11 review with you today for Pythagorean Theorem. So we will have a test on this week. You will have an Into Math assignment for the module review. These are just some similar questions for you guys to help you through the Into Math, or just to refresh, because it's been a little bit since we did lesson 1 or 2. So this first question comes from lesson 1. It says find each missing side length. So what I want you to do is I want you to have a sheet of paper, or these are available to print out if you have access to a printer. But I want you to pause. If you join the live lesson, I gave everyone a chance to work on these before going over them. So just to see, do you understand this question or not? So it's completely on your responsibility to pause the video, work out the problem, then unpause it and see if you got the answer correct. All right. You can always fast forward through me explaining the question, see if you got it correct, and if so, move on. Or if you fast forward and you're like, oh, I didn't get it correct, then rewind it back, and then you can look at how each problem is worked out. So please, at this time, pause your video and try this first question for A and B. All right, so hopefully by now you gave A and B a try. In question A, we're trying to find the hypotenuse. So remember, we use Pythagorean theorem for all of these. So we're just going to set it up as a squared plus b squared is equal to c squared, and we're trying to find the c. So we have 6 squared plus 8 squared is equal to c squared. And then we square these. So we have 36 plus 64 is equal to c squared. If we add these two together, we get 100 is equal to c squared. So now remember, this is where we find the square root. So you take the square root of both sides, and this is a perfect square, so we get c is equal to 10, since 10 times 10 equals 100. So the hypotenuse of this right triangle is 10. So let's do B. So B, in this case, we're looking for a missing leg length instead of the hypotenuse. So we still set it up. A squared plus b squared is equal to c squared. We don't know A at this time, so we're going to leave it just like that. And then we know b squared is 10. So 10 squared is equal to 26 squared. So then we're just going to work it out. 10 squared is 100. 26 squared is 676. So the difference between finding a hypotenuse and a leg, when you're finding the hypotenuse, you add the two leg lengths together. When you're finding a leg, you subtract the square of the leg length from the hypotenuse. So we end up with a squared is equal to 576. So from here, we need to find the square root, because we want to know what a is, not what a squared is. So we find the square root of both sides, and we get a is equal to 24, because 24 times 24 is 576. All right, so hopefully you got both of those correct. If not, that is from lesson 1, so if you need to practice some more problems like that, you can go back and watch the lesson 1 video. All right, next question. Which set of side lengths could form a right triangle? So remember, your hypotenuse is your longest side. I did set these up where you're given your two leg lengths first, then the hypotenuse. But remember, you're looking to see, does the 2 legs squared equal the hypotenuse squared? So go ahead, pause the video now. This was from lesson 2 on the converse of the Pythagorean theorem. So please pause the video and give each one of these a try and see what you're able to come up with. All right, so hopefully you paused the video, you gave this a try, and you found that A and D are both right triangles. So B, C, and E are not. If you did not get that correct, please watch this part so that you understand why A and D are the correct answers. So I'm just going to work out each one. So we have A. We're looking at, does 6 squared plus 8 squared, is it equal to 10 squared? Which I gave it away and told you this one is an answer, but I'll show you why. So we work this out, we get 36 plus 64, and this equals 100. So if we work out this side, 10 squared is 100. So since 100 equals 100, then it is a right triangle. All right, so this one is good. All right, so let's take a look at B. So B is 8 squared plus 10 squared. Does it equal 12 squared? So we have 64 plus 100. Does it equal 144? So if we add these two together, we get 164 does not equal 144. So it is not a right triangle. It is not a right triangle. All right, try to squeeze in C, D, and E on this paper. So here's C. So C is 10 squared plus 15 squared. Does it equal 16 squared? So we get 100 plus 225. Does it equal 256? So if we add 100 plus 225, we get 325. Does not equal 256, so it is not a right triangle. And let's try D right here. All right, so D, I told you, does work out. Let's see why. So we have 12 squared plus 16 squared. Does it equal 20 squared? So we got 144 plus 256. Does it equal 400? So if we add, I'll bring the calculator out for this one. If we add 144 plus 256, oh, hit the wrong button there, it equals 400. So 400 equals 400. So it is a right triangle. All right, and E. E, I'm going to squeeze in somewhere. Let's see where. Maybe we'll just work it out long ways here. So E. Oh, I forgot to circle that D was correct. So D is also an answer. So E, you would have 14 squared plus 18 squared. Does it equal 20 squared? So then if we work that out, we would get 196 plus 324. Does that equal 400? Let's bring out the handy dandy calculator. We have 196 plus 324 is equal to 520. So 520 does not equal 400, so it is not a right triangle. All right, so that was like lesson 2, the converse of the Pythagorean theorem. So now let's take a look at number 3. All right, so at this time, I want you to pause the video and see if you're able to come up with these two missing side links. So this one goes to this. Sorry, I did this in my live lesson. I forgot to erase it, but please don't just try to cheat that way because you're only cheating yourself. So please actually try to work these out and see what you get. Note that your directions are to round to the nearest foot. So that means the nearest whole number. So please pause the video and see if you're able to come up with those two side links. Okay, so hopefully you paused the video. We're going to start with this first side length here. So we're not even worried about this triangle. We're just focused on this one. What is the measurement of that line that goes down my pinky finger? All right, because we can't even find this one until we know this one. So I'm just going to pull this triangle, make a smaller version. And what we know is we know this is 6 and we know this is 12. We need to know what is that side measurement. So since it meets up with the right angle, that means this is a leg. So we're going to do a squared. I'm going to actually do it underneath. That way I have room to the right. All right, so we have a squared plus b squared equals c squared. So we're given one of the side lengths. So we have 6 squared, and we know the hypotenuse is 12. So we have 12 squared. So then we work it out. 6 times 6 is 36. 12 times 12 is 144. And then we don't know the side length of A. What we do know when we're finding a leg is that we subtract from both sides. So I'm going to subtract 36. And I get A squared is equal to, if I take 144 and subtract 36, I get 108. All right, and so now we have to find the square root. So take the square root of both sides. And remember it said rounded to the nearest foot. So we can take 108, hit the square root button, we get 10.39. So we look at the tenths place, the 3 is 4 or less, so we're going to let it rest. So it would be 10 feet. So rounded to the nearest whole number would be 10. So now we know the measurement of this side length, and we can now find this one. Is this your leg or hypotenuse? So if we pull that triangle over here and take a look at it, we now know that this is 10. We know this is 9. What is the measurement of that length there? So that would be our hypotenuse because it is across from our right angle. So let's set it up. We have a squared plus b squared equals c squared. So our leg lengths are 9 and 10. And if we work this out, 9 squared is 81. 10 squared is 100. We add those two together, we get 181. And then we have to find the square root. So what is the square root of 181? So 181 square root. Remember, we're rounding to whole numbers, so the 4 is 4 or less. We let it rest, so C is approximately 13. So we would put 13 here. I forgot to write A, so A was approximately 10. And so this is your final answer. All right, so that was a different type of example of finding a leg length and a hypotenuse. All right, we're halfway through. Now we're going to look at some 3D shapes. So Miss Simon is making a scale model of an Egyptian pyramid. The model is a right square pyramid as shown. What is the base length B of the model rounded to the nearest tenths place? So I want you to pause the video and give this one a try. See what you come up with as far as the measurement for B. And then unpause it and see if you got the same answer as me. All right, so please pause now. All right, so hopefully you gave this a pretty good effort. This question really isn't like one that I think we've done so far, but it is one on your Into Math module review. So what I want you to think about is we are given the measurement of the slant height. We're given the measurement from the tip of the pyramid all the way to the center of the base. And so what we need to know is, what is this measurement? Well, if we take our triangle that we're given here, we have a triangle that we can form right here. All right, and we could actually find this measurement here. Well, what do we know? If that's going from the center to the edge of the square, then that means 2 of these would be equal to the total distance from one side of the square to the other. And we know that all side lengths in squares are the same. So here's what we're looking at. So say you're peeking down, you're looking through the top of the pyramid, you see this square. All right, you see this square. And so right here is the very center of the square. And what you know is this going all the way to the tip of the pyramid is 3.5 centimeters. And then this slant height coming down is 11 centimeters. What we don't know is this leg right here, but we can find it. So we're going to use Pythagorean theorem to find that leg. So I know my hypotenuse is 11, and I know one of my leg lengths is 3.5. All right, so I'm just going to work it out. And decimals, guys, is no different than any other number. You just do 3.5 times 3.5, and you get 12.25. And we know 11 squared is 121. So remember, since we're finding a leg, we are subtracting. So we're going to subtract 12.25 on both sides. And we get a squared is equal to, so 121 minus 12.25 gives us 108.75. All right, so now, remember I said to the nearest tenths place. So now we're going to find the square root. So A is approximately, so if we have 108.75, we find the square root. We're rounding to the tenths place, so the 2 is 4 or less. It tells us to let it rest. So A is approximately 10.4. So when you do this question on the Into Math, I want you to do this part and leave it in tenths place. The one on Into Math tells you to round to the nearest whole number, but don't round at this point to the whole number or you'll get the answer wrong. So when you're at this point, do the tenths place. Okay, so now what did we find? We found that this measurement right here is 10.4. So if we know from here to here is 10.4, that means we also know from here to here would be 10.4. So then we could add them together, or another way of doing repeated addition is multiplying. So you could say B is equal to 2 times 10.4, which would be, so if we take 10.4, multiply by 2, we get 20.8. If it makes you feel better, 10.4 plus 10.4 also gives you 20.8. So either way works for you. And that would be centimeters. So in this situation, I asked you to round to the nearest tenths place. On the question on Into Math, it is whole numbers. So if we were to round this to the nearest whole number, that would be 21 centimeters. So remember, when you're doing this one online, round to tenths place first, then do nearest whole number. Because had we have rounded this one here, we would have said 10, and 10 times 2 is 20. We're looking at it this way. If we rounded to the nearest whole number, it would be 21. All right, next question. The dimensions of a right rectangular prism are shown. What is the length of the interior diagonal D rounded to the nearest 100th centimeter? So this was one of our favorite types of questions from lesson 3. We struggled with these a lot. So if you're still struggling, you're not alone. So here's what I need you to keep in mind with these. You have to do Pythagorean theorem twice to get to D. The reason is in order to find this length here, I need to know these two leg lengths. All right, this forms a right triangle where the hypotenuse is D. So I need to know these two leg lengths. So if I'm looking at the information that I am given, right now I know that this height here is 4 centimeters. So that means every corner of my rectangular prism is also 4 centimeters. So I do know that leg length. So if I pulled this picture out right now, so I'm pulling out that center triangle. Let me try to color coordinate it. So I know this is D. I know this is 4, but I don't know what that length is. So I'm not even able to find D. All right. What I do know is that I could find this length if I'm looking, inside the box. So if I'm looking down inside the box at the base, I see this picture right here. And I know that this is 2 centimeters and this is 12. What I don't know is this leg length that goes like this, which is the same as the bottom of that triangle. So imagine that triangle sitting on top of that line right there. So I don't know that measurement. But since I do know the outside of the box, because if this is 2, this is also 2, I know all rectangles have 4 right angles. So now I can solve this and find the measurement of this diagonal line. Let me scoot my paper up some. Oh, sorry, my computer, I forget that if I don't touch it every so often, it tries to shut off. So give me just a second. Sorry, guys. I think this happened on the last video too. All right, sorry about that. Okay, so we're trying to find this measurement right here. All right, the way we do that is the same way we've been doing Pythagorean theorem. So a squared plus b squared equals c squared. So we know our leg lengths are 2 and 12. I'm going to zoom out just a little bit. That way I have a little more space. All right, so 2 squared is 4, 12 squared is 144. We work that out, we get 148 equals c squared. And now we just need to find the square root. So we get c is approximately, and remember we're rounding to the nearest hundredth place. But at this time, since we're not actually finishing the problem, we're going to leave this as the square root. So we're going to say c is equal to the square root of 148. Just makes it a little easier for us. So we know that this measurement here is the square root of 148, which is the same as this question mark we had right there. So now we know both leg lengths, we can find D. All right, so now I'm going to solve this one. I'm going to work on it over here. So we have a squared plus b squared equals c squared. We know we have 4 as one of our leg lengths. We have the square root of 148 squared as our other leg length. And then our hypotenuse, they're calling D. So I'm just going to change this to D squared. So then I'll work it out. I get 16 plus 148 is equal to D squared. Add these together. I get 16 plus 148 is equal to 164. And then I just need to find the square root. And now it says your final answer, you're going to round to the nearest hundredth place. So if I find the square root of this, the 0 is our hundredth place. So I'm going to look at the number next to it. 6 is 5 or more. So I'm going to raise the score. I'm just raising this number here. So it should be 12.81. So D is approximately 12.81 centimeters. All right, we have one question left. That is from lesson 4. So this was lesson 3. All right, determine the distance between the pair of points to the nearest hundredth of a unit. So this one I did a quick short video on because some of us were like, we don't have graph paper, how do we figure it out? And it's okay, you don't need graph paper to figure this out. So I'm going to set up question or part A right here, but I do need to draw a coordinate plane. All right, so I'm going to graph these. If you like sitting here and doing each line and writing it, you can. I personally don't like to do that. So I'm just going to do just the numbers that I need. So my first point is negative 3, 3. So I'm going to go on the negative direction on the x and then up to 3 on the y. So my point would be right there. All right, then my next point is 1, 4. So 1 would be right here, and then I'm going to the 4 on the y, so my point would be about right there. So now I need to find the distance between these 2 points. All right, well, I can't count diagonally, but what I can do is create legs and use those legs. That's what we learned in lesson 4. So I can meet my 2 points right here. And now I have 2 legs. All right, so now my leg length here to go from 4 to 3 is a change of 1. So that leg length is 1 unit. And then to go from negative 3 to 1 is a change of 4. So to go from negative 3 to 0 would be 3 units, and then we just need to go 1 more. So 3 plus 1 is 4. So this leg length is 4. So we really just have a triangle that looks like this, with leg lengths 1 and 4. So then we just set up Pythagorean theorem. So a squared plus b squared is equal to c squared. And so for A, we have 1. For B, we have 4. And we're just working it out. So 1 squared is 1. 4 squared is 16. 16 plus 1 is 17. And then we just need to find the square root. So we know C is approximately, and they said 100th unit was in our directions, round to the nearest 100th. So 17 square root, we get 4.123. The 3 is the number we're looking at for hundredths place, because the 2 is in the hundredths place. 3 tells us what to do. The 3 is 4 or less, so we're going to let it rest. So C is approximately 4.12 units. So that would be the answer to part C. So the distance between those 2 points are 4.12 units. All right, so now we're going to look at part B. I'm going to shift this up a little bit, and I'm just going to do it the same exact way as A. So I'm going to draw me a coordinate plane, and I'm going to graph my points. So I have negative 6 and negative 4. So going to the negative 6 on the x down to the negative 4 on the y. And it doesn't matter if you're really exact. Really what matters is finding the distance. So just having points there that you can follow. So as close as you can to where it would actually be. And then we have the point 0, negative 1. So we're on the 0 on the x, and we're going to negative 1 on the y. And so our point would be right there on the y-axis. So then we're just going to connect our points. So we're trying to find what is the distance here. All right, we can find the distance there by figuring out what are these leg lengths. Let me use a different color so it shows up. So what are those leg lengths right there? So we just need to know what is the distance between 0 and negative 6. We know that's 6 units. Between negative 1 and negative 4 would be 3 units. So we just have a triangle that looks like this. It's a 3 by 6. And so you should be able to do the same thing we did up here. So squared out, 3 squared is 9, 6 squared is 36. Add them together, we get 45. And then we're finding the square root. So C is approximately, remember we're rounding to the nearest hundredths place. So the 8 is 5 or more, so we let it soar, so that tells us the 0 is now going to be a 1. So C is approximately 6.71 units. All right, and that is our review for Module 11. If you need any further help, please reach out to me on Teams. Hope this helps and hope you do well on your assignment.